So yeah, I'm going to talk about Chassis, which is the missing link between data science and machine learning teams and DevOps teams. And I'll explain what I mean by that. But first, I want to kind of try and describe the problem that we're solving with Chassis and why we built the project. The big problem that we see in enterprise AI across the board is that there's no bridge between your data science teams and your DevOps teams, and this causes a lot of delay and friction. And I've even heard that it takes months to get models into production, even up like 9 months to get a model into production, but at which point you've basically lost the chance of getting any business value out of that model. And so specifically, the problem that we're trying to solve is bridging the gap between this world on the left-hand side of data scientists, machine learning engineers, and this world on the right-hand side of DevOps teams running not just ML, but the whole application stack that a company depends on. So there are a few questions that come up when you look at those kind of two worlds and how they interact, those two kind of different sets of people within an organization. On the left-hand side, yeah, you've got your data scientists asking, like, how can I turn my models that I've logged into MLflow, because loads of people use MLflow, and how can I turn those into production-ready container images that I can run in the platform that my company has chosen? And then on the right-hand side, you've got these DevOps people saying, well, how can I make sure that these container builds happen securely, that I know what's in the containers, that I can build them in a reliable, reproducible way, and how can I build these containers in the same multi-tenant Kubernetes clusters where my data scientists are doing their day-to-day work? And then more broadly, like, how can we make sure that the connection between the data science community and the DevOps community in these companies is a productive one? Because you can't have data scientists trying to send email Jupyter notebooks to a DevOps person and say, hey, can you productionize this? Because that's just not going to work. It's going to be slow. It's going to be error prone, and there's going to be a lot of tickets opened for a DevOps team to look at. And so the solution that we've developed to solve these problems is called Chassis. And Chassis allows you to build it allows data scientists in their data science native environment, like a notebook, to just run one command, Chassis.ml.publish, and automatically create a multi-purpose container image that's built securely that will then run on multiple ML platforms. It automatically pushes the container image that it builds to a container registry for you, and that build happens in a secure environment. And I'll deep dive in a second on why building containers inside containers is hard and how we solve that. But that's a problem that you come across as soon as you try and do this at scale, which every team that's trying to do this is going to have to kind of figure that out from scratch unless they use Chassis. So yeah, there's that whole piece around like avoiding a big security headache there. And so I just want to kind of look at those two camps in a little bit more detail. You've got the data scientists on the left, you've got the DevOps teams on the right. I use the phrase data scientists and ML engineers somewhat interchangeably here, and also DevOps/MLOps engineers, because really a DevOps engineer becomes an MLOps engineer as soon as they try and serve their data science community, as soon as they try and put stuff into production for them. So the benefits of having this approach for data scientists is that you don't waste time learning Docker. So data scientists shouldn't need to be good at using Docker in order to ship models into production effectively. They certainly shouldn't have to understand something as hideously complex as Kubernetes. And it allows them to build images with, like I said, just a simple pip install and then Chassis.ml.publish. It works with every machine learning framework like TensorFlow, PyTorch, scikit-learn, all of them, basically everything that MLflow supports. It works with MLflow, so you can take models that you've logged into your experiment tracker and easily export them into running container images. And it works with Conda, so if you've got some weird, like, specialized computer vision library that you need to use, you can just specify that as a Conda dependency and it will get baked reliably into that container image. It also allows you to specify pre and post processing steps in a native way that makes sense to data scientists, so that when you package your model, you can package it along with the specific code that you need to, like, normalize your images or format your output into a certain into a certain format, or maybe add features to output. And so you can specify all of those steps kind of as you go. And then for DevOps, and on the other side of the house, on the other side of the fence, as it were, is the DevOps and the MLOps engineers. And for those teams, the pitch is really that it's best practice to bake your models into your container images. So I'll take just a moment to describe this, like, distinction. And the industry kind of seems to be split on this point at the moment. Like, half of people do it one way, half of people do it another. The distinction is that in terms of baking models into container images or not, some people just have like a generic container image that at runtime can load a model from somewhere. And so that place might be, for example, an MLflow server. So you can have, that there are some solutions out there that have like a generic PyTorch Docker image, for example, that will, at runtime, it will load its PyTorch model from MLflow. The reason that we don't like this is that it makes your MLflow instance become part of your production infrastructure, because it means that your models can't actually start up unless your MLflow server is running. But MLflow servers are things that you often end up with a multitude of them inside your org, and they're kind of owned by the ML teams in many cases. And you actually really don't want those MLflow servers to be part of your production infrastructure. You want to be able to restart your Kubernetes cluster in the middle of the night and not have to load like 100 different models out of MLflow when they start up. And the same applies when you're scaling these models up and down. You really don't want to have a dependency on MLflow in your production infrastructure. So that's why we believe it's really important to bake your models into your container images. And what I mean by that is that you're literally putting the model files into the Docker image that is built. So that's an important factor from a production readiness perspective, and that's what we one of these selling points for DevOps engineers. And then we're also, from a DevOps perspective, we're empowering. So a DevOps team doesn't work in a vacuum. They work in a business with data science teams and ML teams. And this is about empowering those ML teams to generate production-ready artifacts that just work out of the box in production, that are secure, that are high performance, and that are reproducible. And so that means that the data science teams, by the DevOps team provisioning Chassis and giving access to it to the data science team, it means that the DevOps team doesn't, they'll reduce their own workload, because they won't have any more tickets show up like, oh, can you just take this notebook and build it into a container image for me, please? And this is really about empowering the data scientists to have an interface with production, or have an interface with the DevOps system, which the DevOps team can put the necessary controls and benefits around. So I just wanted to, no meetup talk would be complete without a meme. So this one is, I wanted to talk a little bit about the container security aspect. And the point here is that one does not simply build a container inside a container. And if you haven't actually tried to build one of these at scale model building solutions, then you probably have no idea what I'm talking about. But this is a problem that means that it's actually quite hard to solve this problem in general. And what I mean is that it's difficult. So I'll explain what I mean. So basically, data scientists often work inside a Kubernetes pod, even if they don't know that they're doing it. So for example, if a company's rolled out Kubeflow notebooks, then they're actually running Kubeflow. They're running their data scientists are using Jupyter notebooks that are running inside Kubernetes. And they'll have Kubernetes persistent volumes mounted to them to get them the data they need, and so on. When you're running inside a container, inside a pod, inside Kubernetes, then you can't actually build container images very easily, because the normal way that you build a container image is with Docker build. But if you do that, if you try and do that inside a Kubernetes pod, then it just won't work, because you don't have Docker running inside the pod. Docker's running outside the pod, actually causing the pod to be run. And so you end up with this problem. And it's basically, there is a way to solve this, which is kind of illustrated in this diagram here, which is called bind mounting the Docker socket. And I won't go into all the detail on exactly what that means, but basically, if you say that you want to bind mount the Docker socket to any of your SecOps team or your security people, then they will swear at you. And they will say, no, you should not do that. Because it basically gives you root on the machine, and it's a security nightmare. And so we kind of went around this loop when we were developing Chassis. And the way that we found to solve this problem is by building Chassis on top of a tool called Kaniko. And Kaniko came out of Google. It's actually an open source project which powers the Google Cloud Build service. So it's the same thing that Google uses at scale for building container images in the Google Cloud platform. And what it does is it builds containers entirely in userland. Again, I won't go into exactly what that means right now, but basically it means that you can build container images without needing access to Docker. The problem, though, for anyone who's trying to do this is that Kaniko is just a building block. So if you just gave Kaniko to your data scientists and said, hey, use this to securely build your containers, then they would have to figure out how to post Kubernetes jobs, and they'd have to define their own Docker images and blah, 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 all the stuff that we don't want them to have to do. So Chassis builds on top of Kaniko to provide this centralized service for image builds. It runs securely on multi-tenant Kubernetes clusters. It has this nice MLflow interface so that data scientists can use the language that they're already used to using to describe their models and then push them into Chassis and that Python SDK. And then it also has built-in support for these, what I call multi-purpose container images, because they can run in KFServing, they can run in Modzy, and they will in the future run in a bunch of other places that that people run ML models when they're using them for inference at runtime. Cool. So I've got a short demo. So what Chassis is a way to easily take an MLflow model and convert it into a runnable container that can be run in KFServing or the Modzy platform. So it's like the missing link between MLflow for data scientists and a DevOps team. So we're going to start by just running through this test drive. So what we get here is SSH access to a Kubernetes cluster where Chassis is already running. And we also get access to a Jupyter notebook with a demo that we can run through, and then we're going to run through it. So in order to run through this demo, you need a Docker Hub account. So we can see I've got a Docker Hub account here with my username is Marsden. So we're going to start by importing the Chassis.ml library. That is the Python SDK that allows us to interact with the Chassis backend. So if we just run those imports, then we can go ahead and put together a very straightforward example of an MNIST model that we're going to train here. We're going to also demonstrate that we can set up pre- and post-processing steps in the model. So here we've got a pre-processing step that just divides all the pixel values by 2, and a post-processing step that structures the output in a certain format. We can also define a Conda environment so that we bake in the dependencies that the model needs at runtime into the model. And by the way, MLflow will do this out of the box for you. So these are both the pre and post processing is optional, and also the Conda env is optional. MLflow will do a pretty good job for figuring out what you need out of the box based on what you're already running. And then we're going to save that model into, now that we've trained that model, we're going to save it using MLflow pyfunc save model. And then we can load that model and test that it works when we run it locally. So you can see here the MLflow files. And it's also possible, of course, with Chassis to take models from MLflow and push them to a Docker registry. So now I'm going to put my Docker Hub username and password in here. And then I'm going to construct a little bit of metadata which I need to send to the Chassis service. This points to the name of the MLflow model, the name of the Docker image that I want to create, which is lmarsden/chassis.ml scikit-learn demo latest tag, the path to the files on disk, and my base64 encoded registry credentials. So now I'm going to kick off the job. So that's going to tell Chassis to build that MLflow model that I just provided into a container image, and then I can poll the status of the job by running this command here. So chassis.ml.get job status with job ID. So chassis.ml.publish returns this JSON object which has a job ID field and allows you to poll that job ID field, poll the system with that to check for status. You can see that one job is active. Now, Chassis runs these jobs as Kubernetes jobs, which means you can run multiple in parallel, you can handle multi-tenancy, and it uses Kaniko under the hood, which ensures security within your cluster. You don't need to bind mount any Docker sockets into Kubernetes pods or anything horrible like that will make your security team swear at you. Instead, it all runs in user space inside the containers in a secure way. So if we want to go and check the state, if we actually want to go and see what's going on inside here, it's quite interesting. You can go in here and all of this test drive stuff, by the way, is accessible to anyone on the internet using our test drive capability that we're developing. So here we are going to do logs. We can follow the logs of this, and you can see that it's busy building that container image right now. And once it's finished building the container image, it's also automatically going to push that container image to Docker Hub for us. And then we'll be able to go and see that image in Docker Hub. So notice that from the data scientist's perspective, they didn't have to think about Docker. They only had to think about MLflow. They only had to think about training their model, perfectly standard MLflow stuff, which is like wrapping that model, defining a Conda environment. This is all stuff that data scientists are comfortable with. And then they just run this one command, chassis.ml.publish. They give the model a name. They give it their username and password to access Docker Hub. And then Chassis does the hard work of building it into a hardened container image that can be used in multiple different platforms. So it becomes a super useful container image that can be deployed into whatever context you're using inside your company, whether it's KFServing or if you're a Modzy customer and we're interested in adding support for other types of kind of model runtime environments, maybe like Algorithmia or Seldon or SageMaker or Azure or Domino Data Lab or maybe even Databricks. So okay, let's see how that model build is doing. Okay, so it's still running. Okay, so it's pushed it to my Docker Hub. So let's go and look at Docker Hub now. Okay, so we can see that tag in Docker Hub. You can see that latest tag has been pushed 2 minutes ago. yeah, we easily went from an MLflow model to an image in Docker Hub. If we wanted to, we can also download the tar file and then load it into a local Docker instance. But kind of the whole point of this is that data scientists shouldn't need to touch Docker, really. Yeah, so in the next part of the demo, we'll see how we can load this image into KFServing and send some requests to it. And so what we've got here is we've got KFServing, which is running on a Kubernetes cluster, which is part of Kubeflow. And so what we're going to do is we're going to use that same Docker image that I just pushed, and we're going to define some environment variables. So this environment variable here, interface, is really important because it tells, because basically the model that we've created, remember I called it a multi-purpose model. It can be used for anything. Well, in particular, it can be used, it fits into both the KFServing interface and also the Modzy interface. And the way that you tell the model what to do when it's running at runtime, like which API to expose, is via this environment variable interface. And so if you set KFServing on this environment variable, then it will run as a KFServing model. But you can also set Modzy as an environment variable, and it will run in Modzy mode, which means it will just work on the Modzy platform. You can also define this protocol, which in the case of KFServing defines whether it's speaking the KFServing v1 or the KFServing v2 API. And then we specify the HTTP port and the model name as well, of course. So this is kind of a standard piece of YAML that you define when you are working with KFServing. And so what we can then do is we can apply that YAML that's referring to that container image that I just pushed automatically using Chassis. And then we can see the inference service is starting up. And we can see that that container is creating inside the Kubernetes cluster. And then what we can do is we can set some environment variables that we need so that we can actually make some requests to that model. So let's actually try out the model. Let's send some requests to it. It's an MNIST model. We're going to send it some image data. As soon as that model's up and running, yeah, we're just going to check the logs. Okay, so it's registered the model digits. It's listening on port 8080. And then it's running protocol v1, the KFServing API. And then we're going to run a request, send a request to it. Actually, quickly, I'll show you the JSON that we're going to send it first. So this is some data, some pixel data for some handwritten images or some handwritten digits. We're going to send that data to the model. And as soon as we send the data to the model, to the predict endpoint, and then we'll see it respond with some predictions. And that's it. So it works, basically. So that's Chassis. The final thing I want to say, kind of from a meetup talk perspective, is Chassis is open source and available today. So check it out on github.com/modzy/chassis. Please, if you like what we're doing, give us a star. That's always appreciated. And you can also check out our docs at Chassis.ml. There's a test drive, the same test drive I just showed you. You can run everything I showed you through your browser on the docs homepage. And just as a side note for the DevOps people in the audience, Chassis is available as a simple Helm chart. So you can install it easily on your Kubernetes clusters. And we also provide Terraform for standing up Chassis alongside Minio for object storage in case you're into Terraform. So that's everything I wanted to say about Chassis. I also wanted to mention that Chassis is part of a project called the Open Model Interface. And Chassis is the first reference implementation of this standard that we're working on with other participants in the MLOps community. which aims to solve the problem of fragmentation in the model serving ecosystem. So we're trying to drive consensus around what it means to be a model, what it means to be a model container, and to ensure compatibility between all the different tools, because that's really what users need. So if you're interested in standards around model serving, then please come and get involved at openmodel.ml. We'd love to have you as part of the conversation.